In this video, we're going to talk about the definition of the derivative. So one thing to notice is that even though a lot of this is going to sound similar to the previous video that we did about the derivative at a number, they are related concepts, but they are different. And here the main thing is that in this video we're talking about the definition of the derivative, not the definition of the derivative at a number like in the previous video. Okay, so we have the derivative at a number, which we already looked at, and now we're just talking about the derivative. Okay. All right, so here's the definition of the derivative. Again, this is going to look an awful lot like the previous definition of at a number, but here we won't have a specific number at which we are taking the derivative. So here, so the derivative is denoted f prime of x. So we have x here instead of a specific number in here. And that's the main difference here in all of these spots, is that we don't have a specific number for x. And so what this will be, right, what you will get in the end after you compute this out is a function that gives the slope of the tangent line to the graph at any point or number. Okay, so before, in the previous video, we calculated some examples out. We got number answers. In the first example, we got a 4 as the answer, and in the second example, we got a 6 as the answer. So that's not going to happen here. What's going to happen is when we go through the calculations here, we are going to wind up with a function, a formula, if you want to think of it that way. Okay. All right, so here we go. We're going to use the same function that we used before, f of x equals x squared minus 3, and we're going to find the derivative, f prime of x. Okay, so we're going to use the definition. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so here we don't have a number to plug in, so we're just going to go right to it. F of x plus h, that's what I would get if I went to f over here and I plugged in x plus h instead of everywhere where I saw an x. So the function is x squared minus 3, so I'm going to plug in x plus h right in here for the function. And so here, this is what I would get, x plus h squared minus 3. And then I'm going to subtract off f of x. Well, f of x is just x squared minus 3. So that's what that part would look like. And hopefully all these calculations are going to look pretty similar to you after that. We would need to FOIL this out. So write it out twice, and then actually FOIL it out. Okay, and so FOIL this out, and then combine all the like terms. So x squared minus x squared, they drop out. Negative 3 plus 3, that drops out. Here I have xh plus xh, gives me 2xh here. Okay. So I simplified everything as much as I could. And again, notice just like before, I have an h common, or an h in all of these factors here, or all of these terms rather, and so I can factor it out. So that's what I'm going to do, factor out that h, and then of course cancel. All right, so now I have the limit as h goes to 0 of 2x plus h, right? So this is the limit as h goes to 0. So what you're going to do is take that 0 and put it in for h. Okay, that might look a little strange because you're used to taking the limit as x goes to some number, but here it's the limit as h goes to 0. So you would put that number in for h, and then of course simplify that out. And here's what I get. I get f of prime of x. The derivative of f is the function 2x right here. So what this formula will do is it will give me the slope of the tangent line, that is the derivative of f at some number, if I just plug that number in for x. So if you remember, I went through in the previous video, and we went through the example of calculating the f prime of 2 using the definition, using f prime of 3 using the definition. Those calculations were really similar, and so what you can do is not do it for every little number that you want to find the slope of the tangent line at. You can just do it for x, and you get a formula. And let's take a look at how that would work. right? And so remember previously we found that for f of x equals x squared minus 3, that f prime of 2 was 4 and f prime of 3 was 6. In this video, right, we found that for f of x equals x squared minus 3, the derivative of f was 2x. So here the derivative at 2 is 4, the derivative at 3 is 6, the derivative is the function 2x. And so notice the connection here. If I take the derivative, f prime of x equals 2x, and I plug a 2 in for x, right, then I get 2 times 2 equals 4, which is exactly the result that I had calculating it out the long way. All right? And the same thing is going to happen for f prime of 3, right? The derivative is 2x, right? And so if I want to find the derivative at the number 3, right, then what I can do is just plug a 3 in here. I get 2 times 3, and that comes out to be 6. Okay, so the derivative is a function that gives the derivative of f at any number. So I don't have to go through that limit definition every single time I want to find the derivative at a number. The best thing to do if I had to find the derivative at lots and lots of numbers would be to find the derivative first, right? And then that simplifies the whole process. I just have to go through that limit once, and now I'll have a nice neat formula. And if I want the slope of the tangent line, the derivative at a number, all I have to do is plug in the x value and it will give me the derivative at that number. Okay, so two different ideas right here, right? The derivative at a number, right, gives you the slope of the line tangent to the graph, right, above or below that number. And the derivative gives you a formula or function, right, that will give you the derivative at any number there. So make sure that you realize the difference between the two. Okay.